Pick Computer Science video number 41, where we look at Boolean logic and Boolean operations. So where do these things, Boolean logic and Boolean operators, get their name? Well, they get their name from George Boole, who was a mathematician who was around in the 1800s, and George Boole appreciated maths in its most simplest form. The fact that something can have two states, either a 1 or a 0, or a true or a false, or a yes or a no. And we've already talked about the Boolean data type, and we know that that can only have two possible states, a 0 or a 1. And what George did was he developed this idea, and he came up with the idea that it could be extended and used in something called Boolean logic and logic gates, and in programming, although programming didn't exist at the time, Boolean operations. There's also something called Boolean algebra that we'll need to study, but ready for our next lesson, the things that are starred are the things we need to concentrate on, and we'll look at Boolean algebra later. So back to the Boolean data type. The definition was used to store the logical conditions true or false, often translated to on, off, yes, no, 0, 1, etc. And if we have a series of these and combine the different states and the different combinations of states, we can have quite a powerful piece of logic and a powerful set of instructions. So firstly, what does Boolean operators or Boolean operations mean when it comes to programming? Well, they're also known as logical operators because they help provide some extra logic to our programming. And these add further conditions to relational operators. In Boolean operators, we use commands such as and, or, and not. So if we're testing out a condition, we can use an and, an or even a not to maybe add extra conditions to a test and have more than one condition being tested. Let's have a look at some examples. Here's an example. If the variable DBL salary is greater than or equal to 30,000 and the variable I years in service is less than 5, then do something. So we're testing out one condition and that will return a true or false. We're testing out another condition and that will return a true or false. And then the overall test would be the result of the first comparison and the result of the second comparison taken together, and the whole line would only be true if the left hand side was true and the right hand side was true. Here's another one. Same test done on the left, same test done on the right, but because we use the or Boolean operator in the middle, the whole of the test, the whole line, would be true if either the left hand side is true or the right hand side is true. So both sides do not need to be true, only one of them. If both sides are true, then the whole line is true, and we'll talk a little bit more about that in a moment. And that denotes that if both sides are true, the whole line is true. Here's another one, and note that the not Boolean operator will just act upon one comparison. So we've got if not DBL salary greater than or equal to 30,000. So if this equates to true, then the whole of the line equates to false. So we're basically polarizing what happens on the right hand side by using the not Boolean operator. So if DBL salary is greater than or equal to 30,000, then the right hand side becomes true, but the whole thing becomes false. So if DBL salary was less than 30,000, then the right hand side would be false and the whole line would be true. Incidentally, we could rewrite this statement here with the one at the bottom, couldn't we? What we see on the screen at the moment could be deemed as being a Boolean operation truth table. We'll see truth tables being used in the next couple of videos. with regards to logic gates, and they're an important part of being able to find out what's happening through logic gates. But here, this is just to show us what would happen in programming. So if we've got a comparison operator, and that comparison operator returns true, and we've got another comparison operator, and that comparison operator returns true, and we're using the Boolean operator in the middle here, and it's an AND, then the overall result will be true. If we're still using an and one is true and another is false, then we get false, because both are not true. Left hand side is true and right hand side is not true. Likewise for the opposite, false and true gives false, false and false gives false, true or true gives true, true or false gives true, false or true gives true, and false or false gives false, because neither are true. Then we come down to the nots, which obviously only act upon one operand. So if our first result was true, and we're applying a not to it, then we'd get false, and if it was false and we're applying a not to it, we get true, we get the opposites. In our pseudocode guide from the exam board, all it says about Boolean operators is, well, first of all it calls them logical operators. It just lists the three that we might find in pseudocode in an exam, which are AND, OR and NOT. And it gives us a bit of an example there where these logical or Boolean operators have been used within the condition that's been tested in a while statement. So it's expecting x to be less than or equal to 5 and for a flag to be false in order for that loop to actually execute and for the code within the loop to actually be run. Here's our order of operator precedence that we find in programming, and you'll notice that Boolean operators are very low down in the order of operator precedence. We'd have to do any maths inside a comparison before we can make the comparison, and then we have to make any comparisons before we can actually apply the Boolean operators to get an overall result for a line of code. All should stand to reason, and then finally, of course, we assign any results to variables. I've improved the version of this to include brackets. I think it should really include brackets, and brackets are the thing that are worked out first, just like they are in BIDMAS. You'll need to practice the use of Boolean or logical operators in your programming, but your next job is to find out where this idea of Boolean logic is applied within logic gates, and you'll need to watch these two excellent videos on this topic. And these are the things you might have come across before in other subjects, possibly DT or science, but you're going to need to know them because there's always questions on them in our exams. Hope you enjoyed a bit of an introduction to Boolean logic and its use in programming there, and make sure you watch those next two videos.